Okay, next up is Boris, who's going to be talking to you about a programming language called NodeRED.
Hello, hello. Is it loud here?
Yeah.
So I have to say I'm deeply impressed with those two guys, because essentially from just sending in talk titles, they managed to guess what sort of belongs together. And in the first session after the break, we've seen Wesley talking about the Internet of Things, so essentially components that you can wire up, make internet connectivity, talk to each other. And even now looking at robotics, again, it's autonomous robots driving around, sending information probably somewhere else. So this Internet of Things thingy becomes reality. So what is it? So I should say that Gartner has just in December announced that 2014 is going to be the year of the public awareness of the Internet of Things. So we would all understand what it means. So we have, for example, home monitoring applications where on your iPhone you can see whether someone has broken into your house and whether you should be concerned or not. We can already, whilst we are in the car, over the phone, determine that we want to have a certain temperature at home, and so our boiler is going to heat up. There's energy management. We can power down all not needed applications and power drains. And of course, all sorts of home entertainment multimedia. Your television, your stereo, everything's connected to the internet. It's probably gained some popularity, or at least public awareness, in the last month when Google bought the company Nest. Now, Nest are essentially the market leader when it comes to connecting your home heating system to the internet and make it controllable with the iPhone, for example. And that shows that even those big players have recognized that there's a huge market potential and are getting into it. That's also linked to price developments in that field. So RFID tags are part of the Internet of Things because, of course, there's not going to be a computer where you use your RFID tag. Typically, there is a detector that reads in your specific tag, sends the information to some server that then makes data analysis. And whilst some time ago, for example, these RFID tags were still expensive enough that probably only in a smart car you would employ an RFID tag. In the meantime, small cars have RFID tags. The price comes down even more. Pedal cars and even toy cars will soon have their individual tags. So you can probably control your children where they are by just monitoring where their toy cars are. And if the price goes down even further, what car in the magazine, probably every individual page will have an RFID tag. So these prices are really coming down massively, and everything is connected. So this brings me on to what the Raspberry Pi is used for. Just for the fun of it, I googled Raspberry Pi and robot, as we just heard. I looked for Raspberry Pi and Scratch and Raspberry Pi and home automation. And it's this home automation scheme, really, where this Internet of Things theme comes up again. And what you see is that amongst robotics and Scratch, home automation is one of probably the key areas where people like to use their Raspberry Pis if they don't use them just as standalone computers. Now the reason for that, as you probably know now, is that the Raspberry Pi is great because it's cheap and it offers you an awful lot of input and output possibilities as well as a reasonable amount of processing. So we have the GPIO where we can connect virtually any other electric thing to. We have USB connectivity. We have an Ethernet port that allows us to either wire us up to the internet or by USB to Wi-Fi. We have the Broadcom processor that we can use to process and decide, and based upon certain parameters that we set up earlier, we can then actuate and send information, so either probably switch on the boiler via the GPIO, send information via USB or LAN. And you've seen things like that here before. Everything is already done with the Raspberry Pi. So we've seen the AirPi as a great example how Raspberry Pi can be used to read out an awful lot of sensors, probably 10 on one of these AirPis, and gather information about the environment. Then up there's one of these motor boards or relay boards that can be used to really switch large amounts of current even and control something like a boiler at home. Or when you look at the RASWIC, you have radio systems that help you communicate with sensors around your house. So it's all there. The problem is not the availability of hardware, it's the software. Because typically what you want to do is not yet readily available. And just when we think back about Wesley's talk, there were so many technical details that most of us really don't want to get into. That this is probably still a large deterrent of getting into the IoT, the Internet of Things, on your Raspberry Pi. So in one of my applications at work, I need to monitor a temperature sensor that's living inside a -80-degree freezer. It sends out information using one of these Seco modules, and that information is being captured by a Raspberry Pi that is sitting in, well, comfortable ambient temperature. And what this Raspberry Pi does, it takes that information, creates a plot, so I can anytime really have a look whether my freezer is working as it should. So I did this in Python, and it communicates via the GPIO with the radio modules. I take care of all the data management, create plots of the recent temperatures. Then that plot is being saved as a PNG. It's uploaded to a web server, and there's even a little bit of code that would send me an alarm message once we go over a certain temperature threshold. Something like that ties me up for 2 days over the weekend. It's a pain. So this is where NodeRED comes in. So NodeRED is developed by IBM, and it's developed by 2 people there. And they've been thinking about how we can make it more accessible to use the Internet of Things. So somebody said NodeRED takes the, when I use the word pain, out of programming the IoT. So thinking about a good workflow is hard enough. So essentially you have your sensors coming in, you make some decisions, you have an output node, okay? And what they provide you with is a framework, a graphical framework, where you can, more or less like children do in Scratch, drag and drop together certain activities and wire them all up. And that saves quite a bit of time. So what is NodeRED? It's based on Node.js, which is a framework that can be used, for example, to set up web servers. NodeRED itself presents itself as a website that acts as the graphical user interface that you, as the user, write your workflows with. There are modules that are pre-configured that you can just take, and they are smart enough to know, for example, if you say, I'd like to control the GPIO to do all this talking in the background for you, you just need to say what ping you're interested in and what sort of information you would like to read out of it, as an example. And yeah, there's a huge library of complementary modules that I'm going to show you in a moment. So NodeRED is programmed with JavaScript. So you, as the end user, you have to know a little bit of programming. But you don't have by far, not have to have such a deep knowledge of a programming language as if you would do it from scratch. More or less basic string operations can sometimes be just sufficient to solve your problem of choice. So I have to say, when I first read it's using JavaScript, I had a laugh. I thought it was a toy, because the last time I had a look at JavaScript, it was back in the 90s, and it was used on porn sites to essentially create a pop-up that you could never ever close again. So modern JavaScript, as I now know, is really a fast alternative, and it runs in the background of many, many web applications, and even outside. And there are frameworks, for example, like jQuery, that are used as the backbone of many, many web tools. So it's really well established. And what this Node.js represents is essentially a JavaScript server that you can program. And this is where essentially NodeRED comes in as a middleware that takes an awful lot of things away by just putting a graphical wrapper around it. And you fill in the bits that you're really interested in and that you really, where your detailed knowledge about the process is needed. Yeah, so this is what I just said. Node's a powerful HTTP server. Those 5 lines of code essentially set up a web server that serves simple HTML pages. And if you want to have proper functionality, you would just put more functions into this call. And again, this is nothing that you need to be concerned about, because NodeRED already is that layer on top of it. But it's still nice to know. The power comes really that everything that has ever been written for Node.js is in a library called npm. And you can just seek out the modules that might solve your problem, install them onto your Pi, and then use higher order objects. For example, when you want to deal with complicated regular expression, you just load the appropriate library and plug it into your software. Installing NodeRED on a Pi is a little bit of an operation. It's straightforward, but it involves time, because first you need to install Git if you haven't already done so. So Git is this repository where many open source projects make their source available. Then you need to install a wiring Pi if you want to communicate between NodeRED and the GPIO. Then you need to install Node.js. Then you need to install NodeRED itself, that comes via Git. And then you need to install the modules. Chris Moberly has very kindly provided a very simple to use recipe how to do this. This is the URL.
You can remember that.
I'm gonna put a shorter link to that PDF on screen later on, so you can probably just download it or even just Google it. So once you've successfully installed everything, and I have to say in my case, this entire recipe to install NodeRED was flawless. There was not a single hiccup. It just took a while, and at times it seemed that the computer hangs, but it just took a moment. So this is how NodeRED presents itself to you for the first time when you start it up. So you invoke it with sudo node, so this essentially tells Node.js that something's coming for it. Red.js, it starts up that server, it loads the appropriate modules, and then you are in business. That can obviously happen all in the background. So for example, my personal NodeRED installation at home on that computer, that's usually my children's scratch computer, but it can all happen in the background. However, I can log on to that computer. Yeah.
Just a second, but you had an error on there.
Did I?
It says error MQTT out DDC a double F 3F.
This one.
Second line from the bottom.
That's probably because I have not configured one of the modules that I had in that configuration that I was using at the time. No, the install works perfectly. This is just when it runs. So this is what you would see. So essentially you have here a selection of many nodes that you can use in your workflow. So there are input nodes, listening to the GPIO, listening to Twitter, listening to whatever. You have function nodes that you can use to make decisions, for example. You have output nodes like sending emails, sending tweets, or just having a debugging window. And then you can just drag and drop them together. You can connect them. Just all by using your mouse. Then there's this info window and the debugging window that give you some basic information about your tools. And if you deploy that flow, it's running and it's listening to your ports and it's producing hopefully the desired outcome. The standard nodes that come with a basic Raspberry Pi NodeRED installation, for example, contain an inject node. Inject is quite important because that's how you can manually trigger that something's going to happen, and you can say, well, how does that next node react if I just put this piece of information into it? You can listen to serial communication, so just reading out your serial input. For example, in that case, I do this with these radio modules, for these radio modules. You can even retrieve information from the web using an HTTP object. Outputs are quite similar, so you can either put it into the debugging window. You can use the MQTT node. That's useful if you want, for example, if you want to send your data to a provider like Xively that are usually used for visualization of, for example, weather data. Again, you can send things over a serial connection or even create a WebSocket. Then there are functions. So functions are very much what they are in every programming language, except that this function node is the wrapper around your procedure, and you just have to fill the procedure with some sense. There are switches. So these are very much case statements where you say, well, if some value is greater than this or smaller than this or any other value, then do certain activity. You can listen and write to social media. You can store information. You can read stuff from files, or you can also interact with the GPIO. So my lab temperature monitor that previously was probably 250 lines of quickly cobbled together Python code is then just represented here. So you see, I have a slice of radio in the lab. Once it receives information, it parses that message that's coming from the temperature module. I have a wee look in a debugging window just in case, which is not relevant if I'm not actively looking at the NodeRED GUI. Then, as I have a couple of sensors, I ask what sensor is the data coming from. So there's already in this parse LLAP node there is a little bit of parsing going on where I, from that input string, extract the information, what nodes actually, what temperature sensors actually sending information. Then I extract numerical letters, values with either 4 letters to Skyvely or 3 letters to Skyvely. So that's really just a quick and dirty read between the 7th and 9th character of this character string and return that as a float and then put into Skyvely. I have a freezer alarm that simply just states if the number is greater than X, please email me. And all that stuff down here, that's for operating a sensor that does not have a sleep cycle and comes on automatically, but that I need to manually put to sleep every time I receive the value, so my battery doesn't run low. So all of these like more complicated bits down here, that's really working around a hardware problem. But even those more complicated things are possible with relatively trivial skills of programming. So the information flow is, so all these lines that I've shown you in the NodeRED GUI essentially describe the flow between an envelope. The envelope has a topic and it has a payload. So when my slice of radio first receives information, I would, for example, have AT1. So that's A is just the standard header for these data packages. T1 is my temperature sensor number 1, and in that case, I'm not looking at the temperature, but I'm looking at the battery state. It's at 2.68 volts, and the last dash is really just because every data word that's coming from the radio model has to be 12 characters. So I parse this information, so that's in the ... section, and I then just ask if the payload contains T1 battery, for example, send it to output 1. So that output node, as you could probably see here, has many outputs here, numbered from 1 to 6. Then I just extract that substring that contains the 2.68. I strip away the dash. So that's really all the JavaScript you have to know. It's comparatively little compared to the 250 lines of Python that it previously required. So then now my envelope contains the topic T1 battery and the value 2.68. It's going to Skyvely via this MQTT node, and on the Skyvely website I can see this as a graph and follow over the past couple of weeks or days how that's been going. Lucky you, I'm almost done with the theoretical bit. So first I'm going to show you my streams on Skyvely to show you that it's actually working. I still find that amazing every once in a while. And then I'm going to show you a little bit of NodeRED magic. So, now this is rather confusing now with all this backwards and forwards turning. So what we have here, for example, so please tell me that you didn't crash. So this is one page now, hopefully coming up in a second, that shows the status of one of my -80 freezers, as well as the temperature in my office. The letter just to show to our building engineer that our AC is rubbish.
I don't suppose your office is in a freezer, is it?
No, it's not.
Well, I'm not changing it anyway.
but its temperature is rather unpredictable. Okay, let me see. Yes, so this retrieved its last information a minute ago. Now updates in a second. So over the last day, you probably see the temperature spike shortly before midnight in my office I have absolutely no explanation for that. But at least I think the data is solid. So that's quite nice.
You're making tea, weren't you?
I wasn't in here.
Someone's in your lab.
Temperature.
I wish. So now this is NodeRED. I did not expect that this is so hard on my back here. So what we have here now is 3 different flows. So the first one here takes information from the radio module here. It does a little bit of parsing, and the debug node will spit out the individual characters that are received, as well as the final message that I was able to extract. Unfortunately, I grabbed the wrong sensor when I packed up this morning. This one wakes up only every 5 minutes. So you will see, as soon as I put in the battery, you will see startup messages. Then there won't be anything of interest and importance for 5 minutes until we get the first piece of data. Yeah, reprogramming them is a little bit of pain. So this is essentially the started. Now it tells me that it's 01 and that it's sleeping. I know that. So yeah, give it 5 minutes. Just to excite you, hopefully a little bit, I've also added a node that interacts with the GPIO, and hopefully you see that my little light is on now. So that's my blink example.
Is it possible to view the debug information just by clicking on it, or?
No, you always just see it in that panel next to it. You can log whatever comes out of any node. You can just easily write this into the console. And this is where also this MQTT message from the beginning came from, because it was just telling me that it knew about Excitely, but probably not my login credentials. What's really quite cute, and that I have to say that provided actual proper value this today already. Here I have a flow that after startup, just once it invokes ifconfig. Then I parse out the information, what my internal IP address is, and or actually I think I use NetStat, and then it tweets my internal IP address. And this is how this morning, when I set up this little presentation. So where's my mouse?
I think it just went off the bottom left.
Yeah. So you can see here that about an hour ago, this is probably the break when I set it up, it tweeted my internal IP address, and I was able to log into my Pi headless because I don't like carrying around a large monitor. And that's kind of cute because previously I always used an IP scanner for my Mac, and sometimes it worked, sometimes it failed. So that's pretty good. So let me go back to here. This is really a rather funny one. So I can read Twitter, okay, and I can do a sentiment analysis. So this is one of the nodes that's already provided. So the sentiment analysis tells me whether the attitude, the tone, the sentiment in a tweet is rather positive or is rather negative. Okay, so you get back a score for each tweet. You get back a score for each tweet, and then, for example, if it's a good one, my node would say, "Oh, that was a nice contribution. Thank you." If it's a bad one, I complain with a reason, and that's getting emailed. And I hope I need to show that to you now. So I know I shouldn't do this. This is just going to jinx it, but. So, I hope my internet connection has not died.
Looks okay.
Yeah, well, we had this problem previously, didn't we?
There we go.
Yeah, good. But considering that this just took a second, I don't know what's going to happen. So the expected behavior is that my Raspberry Pi senses that in a second and is probably going to say something like it did 19 hours ago when I last tested this at home. Someone said something nice about the Cambridge event at the extra time. It probably doesn't do it. Now, there's always when you want to present something in a live demo, right? Good. We're finished. Okay. Well, alternatively, I can at least give it a try. That's confusing you probably.
I just wanted to see what he'd do with it.
So let's see if that comes through. So you can see here actually, we just received the temperatures, 22.18 degrees, and those were the individual characters that came trolling in over a second or so.
That's a lie. It came from your office.
So, well, I'm afraid there is nothing I can do about this now.
Looks like it's a connection.
I think it's died.
Yeah, there was quite.
Can you see anything on the debug thing to the Twitter? Does the Twitter one have a debug node as well, or is that should that be showing on the right hand side?
So what hopefully would happen is that as soon as the Pi picks this up,
You got your message had come through there on the right on the screen. You just
Three dots were.
Yeah, you didn't do it to CamJam, you did it at Cambridge Jam.
go back to you.
So it's on the right.
It's on the right hand one.
no, it should listen to CamJam and Cambridge Jam. It should listen to both of them, but apparently it doesn't. That's really annoying now. Oops. So what would happen if it worked is that this good or bad node picks it up, sees that there's something negative has been said. It would then invoke up to see what the current node is, and then send me a rather rude email with the details of the Twitterer who complained, and saying, I just don't have time for this whining under this load, and gives me my current load of the Raspberry Pi, if it would have happened. Well, either way, the NodeRED community is quite friendly. So although they're just two programmers at IBM, if you run into a problem Saturday morning, 2 o'clock, and they're up, you get a response within minutes if you have a technical problem. There's a NodeRED documentation up on NodeRED. There's the Google group that they quite frequently monitor. They're really, really responsive on Twitter. There is a NodeRED IRC channel, and by now many, many man pages on the web. And if you want further information, NodeRED is coming from there. Adafruit just recently had a what is NodeRED and how to use it on their learning system. Chris Mobley's blog post on how to install NodeRED is on this Hardware Hacks blog. Andrew Lindsay, who's quite a name in the Tinker field, has also another blog with a topic on NodeRED development. And well, that's the much shorter URL now if you're interested in this PDF. And if you wish to inform yourself a little more about NodeRED, and I'm coming to my end. Thank you. Now this is shocking. You wouldn't believe how often I tested this over the past week.
It's called Murphy's Law.
What language I used to test this? Awkwardly.